here. So this is example number 22. Example number 22.2. And what I want to do is that I want to calculate the resultant force. Right, so let's take a look at this picture here to see if we understand. Now, the first thing is that we want to identify, so what is the source? Now, it says that we have 3 charges, right? Then it tells me that find the force on Q3. So it means that my Q3 here is my test charge. And my Q1 and Q2, those will be my sources. Then I'm going to ask myself, since Q3 is positive, you see that Q1 is going to push Q3 in this direction like that. And Q2 is going to attract Q3 in that direction. So all what we need to do here is just to add forces. And if you remember, we've done something like this in PSE1. So if you want to add 2 forces, F1 and F2, you need to know the directions of those forces, right? There is 2 ways to add forces. So for example, F1 if I want to add those 2 forces, I can write this as F1x Does that make sense? I can add the x component of F1 to the x component of X2, right? Plus F2, F1, y plus F2y in the j direction. I think this is something that we've seen in PSE1. So if you want to add 2 forces, F1 and F2, you need to take F1 and you write it into F1x and F1y, and then you take your F2, you write it into F1, F2x and F2y, and then you can add up those components. Now, so basically what I'm going to do is that I need to get, so by the way, what is this angle right here? It's 45 degrees. And if this is 45, then what is this angle here? This should also be 45. Right? So it means that, remember that if we want to calculate force, we need to know distance. So I need to know the distance between Q1 and Q3, which is this value. I need to know the distance between Q2 and Q1, which is that value. So if I go ahead here in my next slide, so in the next slide, basically we're just plugging in the number. So if you want to calculate, so in this example here, F23, so it's a force on charge number 3, due to charge number 3, due to charge number 2, and this is F13, so this is from Q1, this is from Q2. Okay. And if you remember, we said that the very first thing is to get these magnitudes. So again, if you just plug in those numbers here, you end up with those 2 forces. Right, so that's just like substituting. We're not really doing anything different. Then we just plug it in the numbers. Now, I can take this vector here and break it in because this is 45 degrees. So I can say that F13x is equal to this. So it's magnitude times the cosine. F13y is magnitude times the sine. And then notice that F23 is only pointing in the negative. So this is the negative I hat direction. So I can say that the total force, so F3x is equal to this, which is this value minus that value, and then this is just this plus 0, because this force does not have any component in the y direction. So if you do everything, you end up with this final value right there. Now, so in the exam, just be very careful with this type of problems here, because again, you need to ask yourself, what is the source and what is the test charge? Right? Once you know the sources, you calculate the distances. If you know the distances, you can calculate the magnitude of the force first. Then if you know what the magnitude of the force is, you can go ahead and then use trigonometry to get the x and the y components. Okay, now let me show you, so I'm going to go ahead and open my other screen here. I want you guys to try this at home. So the problems that I'm going to give you to try at home, when I say try at home, I really mean it, right? Because if you don't try at home and there's something like that shows up in the exam, what happens? So you want to practice and make sure that you can solve those problems. So try this at home. Let's say that I have a charge here. Distance from here to here, 1.0 centimeters. Distance from here to here, 1.0 centimeters. This charge is equal to 3 microcoulombs. This charge is equal to 3 microcoulombs. And this is my point P. So at this point, I'm going to introduce the positive charge. And this charge is 6 microcoulombs. So this is my test charge. Such that the distance from this point to this point, 5.0 centimeters.
What does it mean to be the test charge again?
Say that again.
What does it mean to be the test charge? The one you're gonna like find the distance from?
Right, because remember we said that the test, so we're just going to assume that whenever you have the test charge, this is the charge that can move. And then we're going to assume that the source, so this is fixed. So what I want you to do is that I'm going to calculate the force on the 6 microcoulomb charge. And I want to see the force, both the magnitude and the direction. So look at that example very carefully. So let's think about it this way. Remember that if you have a force, right, what does a force do? A force can cause something to move, right? So what I'm asking you in this problem, like, is that if I were to place this charge right there, how does it move? Right? So how does the force, is it going to move to the left? Is it going to move up? Is it going to move down? Now, let me give you a hint here. So when you solve this problem and you check your answer, the force should be pointing in the j-hat direction. So it means that the force is going to be pointing up. The x components are going to cancel. You're going to end up just with something that is pointing in the j direction. All right, so that's one example right there. That's one example. Then you guys all have this. All right, because I'm going to be switching screens here, so you guys have copied that. All right, so let's move on to the next screen. So this is the second one. The same problem, but now the only difference is that, so again, this is 1.0 centimeters. 1.0 centimeters. This is plus 6 microcoulombs. What was that vertical distance again? 5.0 centimeters. So again, calculate net force on 6 microcoulomb charge. I want to see magnitude plus direction. So the questions that I give you to try at home is an opportunity for you to practice. And I want you guys to really solve these problems, right? If you get stuck somewhere, you can ask me. Maybe set up an appointment for a meeting, or maybe you can ask me in class, right? So try these problems and let's see what you're going to get for these.
The source charge is the same.
Yes, so again, in this example here, this is my test.
Yeah, but are they 3 microcoulombs?
Yes.
Okay.
So this is plus 3 microcoulombs, and this is minus 3. So then the problem is the same unless that here one is negative, right? So just to show you an idea of how this is going to look like. So the force here is going to be pushing. So there is going to be a force like that, right? But then because this is negative, there would be a force like this. So I need to add up those two forces. Now what we're going to see is that because this force, so let's say that this is Q1 and this is Q2. So this will be my F, let's say F13, and this will be my F23. Now because those two forces have the same magnitude, if you add them together, you get this force right here. So in this example, the net force is going to be pointing in the positive I hat. So those are two examples. In the first one, your force is going to be pointing up. In this one, because we've changed the direction of one of the charges, the sign, we've made one to be negative, the net force is going to be pointing to the left, to the right. All right? So try those examples, and then maybe we can discuss that at the beginning of next class, if you guys have any questions. Okay, so now let me move on. Any questions about this?